All right, ladies and gentlemen, our final mini lesson has to deal with solving systems of equations. I'm going to solve the same system of equations two different ways. Once I'll solve it by graphing, and the other way I'll do elimination, or sometimes we call it combinations. I should get the same answer, hopefully, if I know what I'm doing. This is kind of gross. I'm going to not use standard form because I get a lot of decimals. I'm going to convert this into slope-intercept. So when I move this over here, I have 2y equals negative 3x plus 11, and then when I divide everything by 2, I get y equals negative 3 over 2x plus decimal 5.5. That's kind of gross. I'm going to do the same thing down here. When I move 4x, I get negative 4x. I'm sorry. I got to have negative 2y on the left side. Negative 2y equals negative 4x plus 10. And then when I divide everything by negative 2, got to divide everything by negative 2. And be careful, it is negative. Y equals negative divided by negative is positive 2x minus 5. I'm going to graph these two lines and see where they run into each other. So this line, the y-intercept is 5.5. I'm just going to kind of remember that, hey, that's in the middle. That's 5.5 right there. Then I'm going to go down 3 over 2. 1, 2, 3 over 1, 2. So these decimals are in the middle at 0.5. Down 1, 2, 3 over 2. Down, I'll do that a couple times. 1, 2, 3 over 2. So I don't like working with decimals like this, but sometimes you got to do what you got to do. That's blue, and now I'm going to make that blue because it'd be nice and pretty. And now I'm going to do the same thing with the red line. I'm going to graph him. I'm going to start at the y-intercept, negative 5, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Ooh, that might be the point right there. Up 2 over 1, up 2 over 1, and connect the dots. I'll make this guy red. Now, if you're going to do this, especially with decimals, you better check to make sure. So I think that they ran into each other right at that point. And if I went down 1.5 over 1, which is what that really is, I think that that is a point on the line 3, 1. But to check it, you plug it in to make sure that it works. If I plug in 3 for x, 3 times 3 plus 2 times 1, I better get 11. 9 plus 2, yeah, that's 11. Plug it in the bottom one because it's got to work in both. Minus 2 times 1, does that equal 10? 4 times 3 is 12. 12 minus 2 is 10. Yeah, okay, good. So that is a point on the line, but you got to be real careful, especially with these decimals. So 3, 1 is the solution to this system. Now, when I solve it using elimination, I better get the same answer, and I've already checked it, so I know it's right. Elimination is when you add the two equations together to create a new equation that only has one variable. So 3x and 4x make 7x. No x's went away, so maybe this isn't going to work. Well, 2y and negative 2y, those go away. So this is going to work. If I add them together, I get 7x equals no more y's. 11 plus 10 is 21, and make sure you add both sides. If 7x is 21, that means that x equals 3. So x is 3, and it doesn't matter which equation you plug that back into to get y. I'll plug it in the top one. 3 times 3 plus 2y equals 11, and then I can solve this equation for y. 9 plus 2y equals 11. Subtract 9 on both sides. 2y equals 2, which means y equals 1. And that's it for the mini lessons. Ideas.